The Biomedical Research Facility on the School of Medicine campus at UC San Diego is built with the future of the School of Medicine in mind.
We've been very impacted because of constrained space. It has limited our ability to expand programs, to recruit new faculty, or to envision new programs. We've been a bit stymied for the past couple years on this, and the advent of this building now it gives us the bulge, allowing us to bring in some new faculty, which of course have already started to happen, to put together new programs, which have already happened, and to expand some of the facilities for other faculty whose programs are growing.
Beyond providing more space, the Biomedical Research Facility is a hallmark of the School of Medicine's commitment to sustainability. This 196,000 square foot building was designed by ZGF Architects, working closely with the School of Medicine Administration and UC San Diego Facilities Design and Construction, with McCarthy Building Companies Incorporated serving as general contractor. From the start, the Biomedical Research Facility was designed with sustainability in mind. This included considering the building's carbon and energy footprints, water use, and construction waste, as well as using recycled materials in construction. As a result, the Biomedical Research Facility is tracking LEED Platinum certification.
The way we did this is we engage a professional architecture firm, which is very experienced and good at designing research buildings. And then we had a faculty committee made up of people who are in various buildings around here, have had lots of experience, what works, what doesn't work in terms of laboratory space. And that integrated knowledge really came out with, I wouldn't say it's a perfect building, but it's as close to perfect as we could make it.
Because it's very sophisticated and because the systems are unique, it requires a great deal of diligence in terms of all the construction and design professionals that are assembled to create a project such as this. One doesn't often think of the complexity of a building when they go into it. They look at a finished space with the lights and the door and the paint and the furniture and whatnot, but they have no idea that every single piece in that building had some form of human touch in it. It had to be thought of by somebody, it had to be installed by somebody, and it's incredible in that regard.
It's really important in the design of a building that there be a partnership between the designers, the architects and the engineers, the building owner, and the contractor. So from the very start of construction, the contractor has to have separate bins where they recycle all materials that can be recycled so that those don't go to the landfill. The amount of waste coming off of construction sites in the old days was really incredible, and so we've really been able to reduce that to a very small quantity with a very conscious and strenuous program of recycling construction materials.
The Biomedical Research Facility is sustainable architecture at its finest, employing a number of innovative, sustainable building techniques.
Probably foremost in my mind is the use of an exterior dynamic shading system that utilizes the actual sun angle and the time of the year in which the sun is in the sky. Typically, buildings receive their greatest amount of heat gain from direct sun into the windows and then into the building. That translates into higher heating loads and thus cost to operate the facility. This building has what I call a smart system that will evaluate the amount of light in the sky where the sun is relative to the angle of the building and the windows, and will allow the shade systems to operate automatically to provide shade inside the building and not allow direct heat gain, and at the same time allow visibility from the inside to the outside so that the occupants can still, feel the outdoors.
Labs make up 80% of the Biomedical Research Facility. Since safety regulations do not allow air to be recirculated in labs, a lot of energy is spent on air conditioning in traditional buildings. The Biomedical Research Facility saves energy through a more sustainable approach to air conditioning.
We use what's called a variable air volume system, which will modulate down the amount of air that's required to be moved through the labs when there's not a lot of heat load inside the building.
The Biomedical Research Facility also has a revolutionary water capture system.
Often buildings with these type of sophisticated air conditioning systems generate a significant amount of condensate wastewater. Typically that water is disposed of and put down the drain and it's lost water. In this case we have a retention system. So for the operating of the air conditioning system, when the condensation forms on the air conditioning coils, it's collected and goes into a cistern which stores it. It's a significant amount of water because of the kind of cooling load that this building generates. That water is stored and then used for other operational purposes. It will be used to do outside irrigation for the building, as well as being utilized for internal plumbing resources for wastewater for toilet systems.
One of the most important things about designing a green building is to use green materials. And a green material can take a lot of forms, but for wood products, it's to make sure that that's a sustainable ecosystem for growing the trees that we use to make wood flooring, which will be throughout the atrium of the building. The tiles that go into the bathrooms and other areas, that they're using high recycled content. The resilient flooring in the labs has a very high content of recycled materials.
The Biomedical Research Facility makes the most of its available space to provide the maximum amount of laboratories and offices possible.
If you look at the amount of usable space to the amount of total space in the building, it's a very efficient building. Not a lot of wasted space in this building for other purposes beyond the laboratories and the offices.
The office floor-to-floor height is much smaller than the laboratory floor-to-floor. So we were able to gain almost 20,000 square feet in the same envelope by putting additional 2 floors of offices in the north side of the building. And some offices will not be on the same level as the labs, as they will be either half a floor above or below their lab. But with experience that we have from other buildings, it works very well, and the researchers have no problem with it.
The Biomedical Research Facility promotes collaboration. Interactive spaces between labs and in the atrium bring researchers together in ways traditional lab buildings do not.
The Dean's Research Space Advisory Committee sent out a request for proposals for people that wanted to create sort of synergistic groups. We got several responses to our request, and we were able to honor almost all of them. And so we're bringing people together who are not necessarily, say, all from the same department, but they have overlapping research interests, and we're hoping that there'll be some synergy developed by putting people next to each other.
It's also a modular design building. That means that the labs aren't built into discrete rooms like we used to have them. They're modular bays that are all next door to each other without walls in between. And this is a very important feature of modern research buildings because it allows a faculty program to expand and contract as needed without having to go into the next room or be constrained by there's a wall there so you can't go beyond the wall. This kind of flexible design is key to modern research buildings, and also key to allowing really good collaborations between neighbors, who might be in the same floor or the same half of a floor.
I think the other thing that's exciting is there have been changes over, say, the last 20 years in terms of how research buildings are designed. For example, this building, which was built about 20 years ago, the ratio between what we call bench space and special procedure rooms or special areas was about 3 to 1. Currently, the more modern ratio is much closer to 1 to 1, and this building will reflect that. I think science is being done a little differently with more, say, specialized instruments, more microscopy and imaging, more sequencing machines, and things that need those special rooms.
The Biomedical Research Facility exemplifies how UC San Diego's School of Medicine is thinking about the future of healthcare as well as the environment on which we all depend.